This is SpaceTime, Series 22, Episode 79. Coming up on SpaceTime, the universe expanding more rapidly than predicted, solving one of planet Earth's greatest whodunits, and a vital test for the world's largest telescope project. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New observations suggest the universe is expanding far more rapidly than current models are predicting. The findings, reported in the monthly notices of the Royal Astronomical Society, comes on the heels of hot debate over just how fast the universe is expanding, with measurements using different models coming up with different numbers. The new data by the Sharp Holy Cow collaboration is based on a different method of measuring the Hubble Constant, the actual expansion rate of the universe. The team used NASA's Hubble Space Telescope in combination with the Keck Observatory's adaptive optics system to observe three gravitationally lensed systems, the first time ground-based adaptive optics technology is being used to try and obtain the Hubble Constant. One of the study's authors, Professor Chris Fassner from the University of California, Davis, says when he first started working on this problem more than 20 years ago, the available instrumentation limited the amount of useful data that could be achieved out of the observations. But he thought adding adaptive optics for the first time into the full analysis could contribute a lot to the observations. Okay, so what is this thing called adaptive optics? Well, stars twinkle because of distortions caused by atmospheric turbulence due to different temperature layers at different altitudes. Now, while all that might be great for romance, it's not that good for astronomy. Adaptive optics employs lasers to create an artificial guide star at high altitudes, which can then be used as a reference source to compute the amount of turbulence in the atmosphere above the telescope and trigger actuators on the telescope's primary mirror to distort the mirror to compensate for that turbulence. Using the Keck Observatory's adaptive optics system with a near-infrared camera second-generation instrument on the Keck 2 telescope atop of Mauna Kea in Hawaii, the authors obtained local measurements of three well-known lens quasar systems, PG 1115 + 080, AG 0435 - 1223, and RxJ 1131 - 1231. Quasars are extremely bright active galaxies, with massive jets powered by feeding supermassive black holes. Though quasars are often extremely far away, astronomers are able to detect them using things like gravitational lensing, a phenomenon that acts like a magnifying glass. When a sufficiently massive galaxy close to the Earth gets in the way of light from a more distant object, say a quasar, that intervening galaxy can act as a gravitational lens. Its gravity field literally warps space-time, thereby bending the background quasar's light into multiple images, making it look extra bright. At times, the brightness of the background quasar flickers. That's because each image corresponds to a slightly different path length from the quasar to the telescope. So the flickers appear at slightly different times for each image because they don't all arrive at Earth at the same time. So the authors measured these time delays, which are inversely proportional to the value of the Hubble Constant. This allows astronomers to decode light from these distant quasars and gather information about how much the universe has expanded during the time it's taken the light to travel from its origin, the quasar, all the way to the Earth. Based on their readings, the authors arrived at an estimate for the Hubble Constant of 76.8 kilometers per second per megaparsec. A parsec's a bit over 3 light years, which equates to just over 30 trillion kilometers, and a megaparsec is a million parsecs. So 76.8 kilometers per second per megaparsec, that's the rate at which the universe is expanding, according to these authors' calculations of the Hubble Constant. But in 2017, the Holy Cow team published another estimate for the Hubble Constant of 71.9 kilometers per second per megaparsec. So we have a bit of a discrepancy there. But the new Sharp Holy Cow estimates are comparable to that by a team led by Adam Rees from Johns Hopkins University, which found the Hubble Constant to be at 74.03 kilometers per second per megaparsec, using measurements from a set of nearby variable stars known as Cepheids. Now, while all these readings do differ somewhat from each other, they're all reasonably close together. By comparison, they're very different from estimates of the Hubble Constant from an entirely different technique based on distant observations of what's known as the cosmic microwave background radiation. It's the leftover radiation from the Big Bang, when the universe began 13.82 billion years ago. Now that method gives a Hubble constant reading of 67.4 kilometres per second per megaparsec, assuming the standard cosmological model of the universe is correct. Meanwhile, another estimate, this one by Wendy Friedman and colleagues from the University of Chicago, did come close to bridging the gap with a Hubble constant of 69.8 kilometres per second per megaparsec, based on the luminosity of distant red giant stars and supernovae. The new Sharp-Holicar team results add to the growing evidence there must be some sort of a problem with the standard model of cosmology, which shows that the universe was expanding very fast in its early history. That expansion then slowed down due to the gravitational pull of a mysterious substance called dark matter, and now the expansion's speeding up again due to another mystery, a force called dark energy. And therein lies the crisis in cosmology. While the Hubble constant is constant everywhere in space at a given time, it's not constant in time. So when comparing Hubble constants that have come out of various different techniques, scientists are comparing the early universe using distant observations with more recent parts of the universe using local nearby observations. This suggests that there's either a problem with the cosmic microwave background radiation measurements, which the team says is unlikely, or the standard model of cosmology needs to be changed in some way, using new physics to correct the discrepancy. You're listening to SpaceTime. Still to come, astronomers and engineers complete a test run to determine whether today's technology can cope with the enormous amounts of data expected to be streaming from the world's largest telescope once it's built, the Square Kilometre Array. And later on the science report, we know roughly when humans, Homo sapiens, began. And now we may also know exactly where they began. I don't just mean in Africa, I mean the exact part of Africa the first Homo sapiens evolved in. All that and more still to come on SpaceTime. Well, it's one of the great whodunits in planetary science, isn't it? What killed the dinosaurs? Was it an asteroid impact? Or was it volcanism? Or was it a combination of the two? Well, a new study has confirmed, wait for it, it was an asteroid impact rather than volcanism, which triggered the mass extinction event 66 million years ago that wiped out 75% of all life on Earth, including all the non-avian dinosaurs. The findings, reported in the Journal of the Proceedings of the National Academy of Sciences, speaks against the hypothesis that ecosystems were already under pressure from increasing volcanism, causing a gradual deterioration in environmental conditions in the period leading up to the celestial collision. The new findings are based on fossil remains of tiny algae, which not only provide information about the end of the dinosaurs, but also show how the oceans recovered after that fatal asteroid impact. The KT, or Cretaceous Tertiary Boundary Event, which these days is often referred to as the KPG, or Cretaceous Paleogene Extinction Event, occurred 66 million years ago, when a 10 to 15 kilometre wide asteroid slammed into a shallow sea off the coast of what is now the Gulf of Mexico's Yucatan Peninsula. That impact released as much energy as 100 teratons of TNT, more than 1 billion times the energy of the Hiroshima or Nagasaki atomic bombs used to end World War II. The collision triggered one of the largest mass extinction events in the history of planet Earth. The initial impact created the 180 kilometre wide Chicxulub crater, throwing molten ejecta and debris high into the atmosphere and triggering a massive tsunami hundreds of metres high, together with devastating earthquakes, some so powerful they're called land tsunamis, and it triggered volcanic eruptions which shook the entire planet. Shockwaves from the collision circled the entire planet, causing it to literally ring, while burning debris from the impact ejecta began raining back down onto the surface, causing an intense pulse of infrared radiation which, quite literally began cooking any life exposed to it, and combining with the molten lava flowing from volcanic eruptions to spark global wildfires which devastated vast areas of the planet's surface, burning out vegetation and killing any animal life on the surface that survived the initial blast wave. Worse still, the asteroid impacted the planet at a location rich in sulfate-containing gypsum, which was instantly vaporized and dispersed as an aerosol into the atmosphere, only to rain back down as highly caustic acid rain, burning anything it touched and causing long-term effects on the climate and food chain. Smoke and ash from the wildfires and volcanic eruptions, together with dust from the ejected debris, initially created a blanket-like greenhouse effect, preventing heat from below from escaping into space and causing surface temperatures to soar. Eventually, over months or years, temperatures cooled as the smoke, ash, dust and ejected debris high in the atmosphere blocked out sunlight, creating an impact winter that caused temperatures to plummet. Now, somewhere around the same time, massive volcanic eruptions in what is now India, known as the Deccan Traps flood basalts, began flowing across the subcontinent, pumping out more toxic gas and pollution to the atmosphere, further contributing to the growing impact winter. Evidence for the global nature of this asteroid impact event can be seen around the entire planet in the form of a dark boundary line in the geological record. Known as the KT boundary line, this ash layer contains high levels of the metal iridium, which is rare in Earth's crust but abundant in asteroids. One of the new study's authors, Michael Heenan from the GFC German Research Center for Geosciences, says the new data shows there was a sudden impact that led to massive ocean acidification, not a gradual build-up, and that means the asteroid impact did it. The authors reached their conclusions after reconstructing the environmental conditions of the ocean using fossils from deep-sea drill core samples and from rocks that formed at the time. They studied isotopes of the element boron in the shells of plankton. Now, importantly, before the impact event, they couldn't detect any increasing acidification in the oceans. And yet, right after the impact, the oceans became so acidic that organisms that made their shells from calcium carbonate couldn't survive. Because of this, as life forms in the upper layers of the ocean became extinct, carbon uptake by photosynthesis in the oceans was reduced by half. This state lasted for tens of thousands of years before algae containing calcium carbonate began spreading again. However, it took several million years before the fauna and flora recovered and the carbon cycle had reached a new equilibrium. The researchers found decisive data for this during an excursion in the Netherlands, where an especially thick layer of rock right on the Cretaceous-Paleogene boundary is preserved in a cave. It seems a rare, especially thick layer of clay from the immediate aftermath of the impact accumulated in the cave. In most settings, sediments accumulate so slowly that such a rapid event like an asteroid impact is hard to resolve in the rock record. But because so much sediment was laid down there at once, it meant the authors were able to extract enough fossils to analyse and were able to capture the transition, providing hard evidence that the asteroid did it. You're listening to SpaceTime. Still to come, how to live off the land on the moon, and we look at some of the new nominations for the Australian Skeptics Bent Spoon Award. If you'd like to help support SpaceTime and the great work we do promoting science, then why not come and join our Patreon family? For just a few dollars a month, you'll get access to a slick commercial-free double-episode version of SpaceTime every week, as well as extended interviews not included in the show, and an invitation to join our special Patreon-only Facebook group where you can come and chat, discuss the show, ask questions, whatever you want with like-minded listeners and our team. You can get all the details at patreon.com/spacetime with Stuart Gary, where you can see the various reward levels we have and what works for you. And of course, most importantly, you'll be helping to support our show and the work we do to deliver the wonders of the universe to everyone. Now that URL again is Patreon, spelled Patreon, patreon.com/spacetime with Stuart Gary. And of course, you can find the details in the show notes or just click the orange button on our website. And thanks to all our patrons, because it's your generosity and support that helps keep our show going. Astronomers and engineers have completed a special test run to determine if today's technology can cope with the enormous amounts of data expected to be streaming once the world's largest telescope, the Square Kilometre Array, or SKA, is up and running. Scientists from the International Center for Radio Astronomy Research in Perth, the Oak Ridge National Laboratory in Tennessee, and the Shanghai Astronomical Observatory used the world's most powerful supercomputer, Summit, at the US Department of Energy's Oak Ridge facility to process simulated observations of the early universe ahead of the giant telescope being built in Western Australia and South Africa. Summit is so powerful it can perform 200,000 trillion calculations per second. Scientists tested data pipelines processing some 400 gigabytes of data per second, equivalent to more than 1,600 hours of standard definition YouTube videos every second. The Director of Data-Intensive Astronomy at the International Center for Radio Astronomy Research, Professor Andreas Wisenek, says it's the first time radio astronomy data has been processed on this scale. He says until now, astronomers really had no idea if they could take an algorithm designed for processing data coming from today's radio telescopes and apply it to something 1,000 times bigger. Completing the test successfully tells scientists that they will be able to deal with the data deluge generated by the SKA when it comes online in the next decade. Construction of the SKA is expected to begin in 2021. But the fact that they needed the world's biggest supercomputer to run this test successfully shows that the SKA's needs are at the very edge of what today's supercomputers are capable of delivering. The billion-dollar SKA is one of the world's largest science projects. It's up there with the CERN Super Collider and the International Space Station. In fact, the low-frequency part of the telescope alone is set to have more than 130,000 antennas in the project's initial phase, and that'll generate around 550 gigabytes of data every second. Oak Ridge National Laboratory software engineer and researcher Dr. Runan Wang, a former International Center for Radio Astronomy Research PhD student, says the huge volumes of data used for the SKA test run meant the data had to be generated on the machine itself. So scientists used a sophisticated software simulator written by researchers at the University of Oxford and gave it a cosmological model and the array configuration of the telescope so it could generate data as if it was coming from the telescope observing the sky. Now, usually the simulation runs on only a single computer, generating just a fraction of what the SKA would produce. So, they used another piece of software, this one written by the International Center for Radio Astronomy Research, called the Data Activated Flow Graph Engine, or DELUGE, to distribute one of these simulations to each of the 27,648 graphics processing units that make up Summit. They also used the adaptable I/O system ADIOS developed by the Oak Ridge National Laboratory to resolve the bottleneck of trying to process so much data at one time. The test run used was a cosmological simulation of the early universe, at a time known as the Epoch of Reionization, when the first stars and galaxies formed that became visible. Wissenek says the data was first averaged down to a size 36 times smaller and was then used to produce an image cube of the kind that can be analysed by astronomers. He says, finally, the image cube was sent to Perth, simulating the complete data flow from the telescope to the end users.
We've essentially planned to do a test since quite some time already, to do it at scale. And that scale means we wanted to be able to produce the data as it would be produced by the telescope. Obviously, the telescope doesn't exist yet, so we have to do simulations. And the simulations have to be run on fairly big computers because what the telescope would be producing is a very large data set.
And that's where Summit came in.
Exactly, that's where Summit came in. Actually, we tried to do that previously on a Chinese supercomputer as well, and we never went to that scale, but pretty far as well at that time, already a couple of years back. And then in the meantime, of course, the software developed quite a bit, and we did a lot of work on it and tried to do even more. And then Summit came along, and we had the opportunity to use that machine due to one of my PhD students going over there to Oak Ridge, where the computer is located, and giving us that opportunity in terms of director's discretionary time in this case.
This was a hell of a simulation, something like, 400 gigabytes of data per second, equivalent of 1,600 hours of standard def YouTube videos. It's a lot of cat videos.
Yeah, that's a lot of videos, yes.
What were you guys actually testing, the pipeline itself or what?
So we are still in what's called pre-construction state. Pre-construction means that none of the final systems have been defined directly, and only after that, so we are still before what's called the construction book being released, and that will then finally also define how the hardware looks like, even how the antennas look like in detail, and only then we start going out for tender for the construction phase. So that's hopefully going to start middle of next year or so, but still quite some time to go. So what we've tried to do there is, well, as you're saying, essentially trying to figure out whether we can actually handle the data when it comes out of the array. So that's both software-wise but also hardware-wise. We are not too much involved into hardware testing as such. So our main goal is to see how the software is going, how we can distribute the load onto many computers, like the 4,908 or something like that on Summit. So we are trying to make sure that we can actually handle all that load and have the facilities in terms of software to have as small as possible overhead to manage that kind of distribution. So that's one part on the capturing side, but then on the what we call imaging side. So we take the data which is produced and produce essentially an image out of that again. That's more on the algorithmic side. And we have some issues to get that scaling, and we are trying to address them. For the time being, we are not quite yet there. So the image side is fine. The imaging side is still a challenge, but we still have a few years, so we are quite confident that we can reach that as well.
You guys must be really keeping your fingers crossed that Moore's Law works for you.
Oh, yeah. So it's actually quite interesting because the SK as such as a project was based on essentially Moore's law being valid still, because when it was planned like 15 years ago already, it was clear we couldn't build it because we can't process the data. And then people said, okay, well, we have Moore's law here. How does that fit in terms of timeline? And just around now, when you look at Moore's law like 15 years ago, it would have hit the possibility to be able to build something like this. So we are just on top of this. And actually, if you look in the early planning documents for the SK, you will see Moore's law featuring there anyway.
Have you kept up with the latest claims by Google regarding its Sycamore quantum computer and what that's capable of doing?
Yes. So we actually do have a look into that, but there are only a few algorithms which would be potentially even to run on such a platform. And of course, they don't exist yet. So it's quite a futuristic thing, and I don't think we'll go close to that anyway soon. But well, we definitely keep an eye on that and see whether we can make use if it's coming up along. We don't know. I mean, for the time being, it doesn't look like, but maybe
further
in a
down
few
the track
years from now. That could well be. And of course, the SK is a very long-term project, 50 years lifetime projected. So within those 50 years, a lot can happen, and then we may have a quantum computer doing that stuff. That could well be.
What's the current plan in terms of the computers being looked at for the SKA? Will there just be one big computer in Manchester or somewhere? Or will there be two supercomputers, one in Perth, one in somewhere in South Africa? What's the current plan?
So the plan is to have one computer here in Perth. That's where I'm sitting. And another one in Cape Town. So they are dedicated to the data flow from the respective instruments, the MID telescope in South Africa and the low frequency telescope here in Western Australia. And so there's a dedicated network for both of them. And in both cases, it's quite similar distance, about 700, 800 kilometers dedicated fiber connections. And the first stage of the processing will happen there, essentially, of real imaging processing and that kind of stuff. And then data will be distributed around the world to the scientists to do their post-processing. And one major part might be in Manchester, but maybe somewhere else in Europe as well.
Will these be the biggest computers in the world when they're built?
No. So what we are requiring there is about the biggest computer right now. And that's still assuming that we only be able to have a kind of a 10% overall efficiency. So we have always that margin because efficiency is quite an issue to make everything efficient from the gathering of the data to the output to final storage. And get to 10% is quite a challenge. So right now we would have to buy the biggest computer, but within the 5-6 years of construction, we will have quite a kind of modest computer at that point in time. So it looks quite feasible in terms of money as well.
This is SpaceTime. I'm Stuart Gary. Space experts from all over the world have met in the European municipality of Luxembourg for a special conference on utilising space resources to explore the solar system. Getting fuel, oxygen and water up into space from Earth remains the most expensive part of any mission. So, being able to develop these resources in space would make space travel far more accessible. Among the advances discussed at the Luxembourg conference were new technologies to extract water from lunar soil returned to Earth by the Apollo astronauts. Hannah Sargent from London's Open University presented her work on heating the oxygen in the lunar regolith to 1,000 degrees Celsius with hydrogen in order to create water. Now, having proven this is possible on Earth, development has started on an instrument to be part of ESA's Prospect drill that will eventually fly on the Roscosmos Luna 27 mission to the southern polar region of the Moon. If robots or astronauts could mine for water on the Moon, they could use it to create fuel and oxygen for rockets and life support. Prospect will carry a drill and sample analysis package designed to bore down under the lunar surface to depths of over a metre in minus 100 degrees Celsius temperatures, searching for water ice and other chemicals. Prospect's miniature laboratory called Prosper will then analyse the soil samples retrieved by the drill. The data will help unearth details about the Moon's history. It'll also help determine if future explorers could use lunar resources on their missions to help them set up lunar bases. See, the lunar south pole is of great interest to lunar researchers and explorers because the low angle of the Sun over the horizon leads to areas, especially in deep craters, which will either be partially or completely in shadow. These shadowed areas and permanently dark crater floors where the sunlight never reaches are believed to hide water ice and other frozen substances to better understand the natural processes that form them and use to produce resources such as oxygen and propellant. Meanwhile, another researcher, Beth Lomax from the University of Glasgow, showed how a method called molten salt electrolysis could be used to turn lunar regolith into a mixture of metal alloys while extracting oxygen. Both the oxygen and the metal could then be used in future by settlers on the moon. So, the conference has shown how the next era of space exploration won't require agencies to launch everything they need from Earth, but instead they can use elements already on the planets and moons being explored to make what they need. This report from ESA TV.
Prospect is really one of the stepping stones between the early robotic phase that we're seeing now and the future where human activity on the lunar surface may make use of lunar resources in order to have a sustainable presence on the lunar surface.
If you land anywhere on the moon, you can extract oxygen. If you land at the poles, it may be a little easier because you can get to water and other volatiles that might be there. And so volatiles are things that can be very mobile, so they can sublime into a vacuum. But obviously they're of interest to us because we can breathe and drink them. So water ice, for example, is thought to be abundant at the lunar polar regions.
So Prospect is a combination of a drilling and sample analysis package. The drill will drill down to depths of up to 1 meter below the surface. So it's not the first time that drilling has been employed on the moon, but it's the first time that it will have been done in these polar regions.
We are now going to test the first model that has been built. We are going to test it, so to see if the drill works, all the instruments and mechanism works perfectly, and we are going to perform some drilling tests and sampling coring and sample delivery to the sampling system.
We collect 2 samples while after drilling. One sample is collected using a dedicated mechanism that allows to collect the sample and close the chamber after the collection. So we keep the sample within a dedicated chamber for the Russian sample. And then we perform the same operation with the for the European instruments.
We don't know exactly how much water ice we might find. So in the tests, we're doing some that are dry, which have no water ice in. For others, we inject a little bit of water, and then we range up to saturated regolith, which has a very high fraction of water in the subsurface.
One of the tests on which I am more curious of is the test with the 6% of water content. So we will weight the percentage of the water, we will mix like an ice cream making, and then we will froze the simulant down to the minus 150 degrees C.
Under lunar vacuum, when you have an icy material, as soon as you expose it to higher temperatures, it immediately sublimates into the vacuum. So it doesn't go through a melting point, it just disappears into a gaseous form and you've lost your sample.
The point is, during the drilling, you are producing heat due to the mechanical attrition of the drill tip and the lunar soil. This is unavoidable. So what we are doing is to balance the power injected, controlling the rotation of the coring and the rotation and the speed of the drill in order not to go too fast and so not to produce too much heat.
The PROSPA is the European instrument that is part of Prospect. It will be based on miniaturized oven, which will receive the samples from the drill. It will seal the ovens and it will perform the measurement of the contents. PROSPA contains a small carousel and with a disc on which 25 ovens are mounted. We started many years ago in studying coring and drilling systems. Actually, the first drill that went to space was the Rosetta Drill for the Rosetta mission.
Prospect has a great heritage from Rosetta, from the conceptual point of view, because there is the task of drill, there is the task of collect the sample, and to deliver the sample to the instrument, and the in situ observation of the material.
Our objective is not just to fly the single Prospect payload, but also to put Europe in a position where we can also work on the topic of lunar resources in the context of other payloads, and really to develop the expertise of the community in this area, which is already happening today.
From an exploration point of view, it has the potential to change the moon from a thing that we see in the sky to a place that we can go. By understanding how we can use the resources that are there, it then opens the door for other people to potentially exploit those resources.
We really hope to go to the moon very soon, and a few years from now, so this is really exciting and it has just begun.
My hope is that with missions like Prospect and the missions we're seeing coming up, that this is actually opening a new door to lunar exploration, which might actually see a bigger participation of the public, and perhaps even see my children or grandchildren participating in that exploration and visiting or even living or working on the lunar surface.
Space resources has gone from something that nobody was really thinking about to something that's really becoming very exciting, with huge activity, a large and growing community with science, engineering, technology, industry, academia, business, all of coming together to really do something extraordinary.
Curiosity to venture out into the unknown, and the opportunity to bring back knowledge and capabilities only possible by exploring, by going out there.
Moon will be the place where we learn how we can use local resources. We need to do a lot of research, prospecting, technology demonstration.
If you extrapolate far enough in the future, we have to get beyond the limit of our planet. This is the century that we can start putting industry off the Earth.
The gateway design enables an open architecture. It enables to introduce reusability, in particular of the human lander.
If we plan on having sustained operations, building up an infrastructure to support these things, so landing pads, berms, habitats.
While building a new space economy. Resources are the key for that space economy, so we really need to focus on that.
How do we try to move from the 20th century institutions and goals and frameworks to a 21st century vision for what works best for humanity? And space is such an important answer to that question.
We can support the investment in it from a public perspective for commercial services to get into space resources, but most importantly to serve our astronauts on the moon in sustainable exploration.
Create a new space resource research center in Luxembourg. There will be an initial budget to do so of about 5 million euros.
With Luna 27, we are hoping to successfully produce water on the moon for the first time.
We've turned a lunar regolith simulant into metal by pulling the oxygen out. That's pretty awesome.
Not only space people are participating, but now you have the mining, the oil and gas industry, investors. Seeing the level of excitement this week was just incredible.
The moment is right to do big, bold, and exciting things.
And in that report from ESA TV, we heard from ESA Prospect Project Manager Richard Fascally, ESA Prospect Project Scientist Elliot Sefton-Nash, Prospect Project Manager for Leonardo Andrea Zamboni, Proceed System Engineer with Leonardo Christian Panzer, Leonardo Project Engineering Manager Andrea Risconi, Leonardo Software Engineer Patrizia Bologna, as well as James Carpenter, David Parker and Bernard Halfenbach from ESA, Philip Metzger from the University of Central Florida, Gerald Sanders from NASA, Clive Neal from the University of Notre Dame, Noah Rayford from the Dubai Future Foundation, Matthias Link from the Luxembourg Space Agency, Hannah Sargent from the Open University, and Angel Madrid from the Colorado School of Mines. And time now for a brief look at some of the other stories making news in science this week with a science report. A new study claims the ancestral homeland of every human alive today is in the southern African countries of Botswana, Namibia and Zimbabwe, south of the Zambezi River. Scientists from the University of Sydney and the University of New South Wales who led the study say while researchers have known that Homo sapiens originated around 200,000 years ago, exactly where they originated from has remained a mystery until now. A report of the journal Nature claims researchers pinpointed the first place humans called home by looking at the genetic code of mitochondria, the cell's energy factories, from 1,000 living southern Africans. See, mitochondria DNA is inherited down the maternal line and so allows tracking. The DNA data was then combined with linguistic, cultural, historical, geographic and archaeological data to establish a trajectory back in time, revealing that humans most likely emerged from the Makati-Okavango paleo wetland of southern Africa. It's an inhospitable place nowadays, dominated by desert and salt pans. But it was once home to an enormous lake twice the size of modern Lake Victoria. But roughly 200,000 years ago, the lake began to break up, creating a vast wetland. The authors say the earliest Homo sapiens appear to have thrived in the area for 70,000 years before they ventured out of the homeland. Reconstructing climate conditions, the authors provided evidence that climate change opened up other areas of Africa, eventually leading to mankind's domination of every corner of the planet. A new study has found that climate change-induced warming in the Western Pacific since the late 1970s has shifted El Niño events to start there instead of their usual starting spot in the Eastern Pacific. The findings, reported in the journal The Proceedings of the National Academy of Sciences, also confirmed that this change is causing more frequent extreme El Niño events. Scientists discovered a developing pattern among 33 El Niño events that occurred between 1901 and 2017. They also found that 4 of the 5 extreme El Niño events happened after 1970, and suggest that further warming of the Western Pacific is likely to trigger more extreme events in the future. And that's bad news, because El Niño events cause serious shifts in weather patterns across the globe, including storms and floods in the Americas, and droughts and wildfires in Australia. Google claims its Sycamore quantum computer has just performed a calculation that even the most powerful conventional supercomputers can't reproduce. It claims Sycamore's achieved what's called quantum supremacy by completing a complex computation in 200 seconds that would have taken the most powerful conventional supercomputer some 10,000 years to finish. Developed by scientists at the University of California, Santa Barbara, Sycamore completed the task by using a chip consisting of just 53 qubits, the quantum version of the bits found in everyday computers. Ordinary computers perform calculations using bits of information, which, like on and off switches, can exist in only 2 states, either 1 or 0. But quantum computers use quantum bits or qubits, which can exist either as 1 or 0, or as both 1 and 0 simultaneously. So a pair of bits can store just one of 4 possible combinations of states 00, 01, 10 or 11 at any given time. But a pair of qubits can store all 4 combinations simultaneously because each qubit represents both values 0 and 1 at the same time. And if you add more qubits, your quantum computer grows exponentially. So 3 qubits can store 8 combinations, 4 qubits can store 16, and so on. With 53 qubits, Sycamore can store some 253 values, or more than 10 quadrillion combinations. And with things like quantum entanglement, Albert Einstein's famous spooky action at a distance, if the qubits in the quantum computer are entangled, which they are, they can all be measured simultaneously. A new study has found relocating koalas out of overpopulated areas has improved their chances of survival. The findings, reported in the journal Wildlife Research, looked at the health and survival of 36 koalas who had been relocated from Cape Otway in southern Victoria to an area of the Great Otway National Park near Anglesey. They found that while the relocated koalas initially lost some body condition, they regained it within 4 to 5 months and ended up better off than koalas who were left in place to compete for the available habitat. The researchers say their results give support for relocation as a management strategy to reduce the density of koalas at sites where overbrowsing is a concern. A report by the Food Safety Information Council warns that a survey has confirmed that more than 20% of Australians admit that they don't always wash their hands after going to the toilet. Presenting the findings at the Accord Cleaning and Hygiene Conference in Sydney, researchers also warned that the public health risk could be even greater, as nearly 40% of respondents also admit they didn't always wash their hands before touching food. The supermarket chain Aldi has been added to the inglorious list of nominees for the Australian Skeptics 2019 Bent Spoon Award. Named in honour of Uri Geller and his claim to be able to bend spoons with only the power of his mind, the Bent Spoon Award is presented annually to the perpetrator of the most preposterous piece of paranormal or pseudoscientific piffle of the year. Past winners to be condemned forevermore include the University of Wollongong for giving a doctorate to a student who submitted an anti-vaccination PhD thesis, and the Southern Cross University for offering a degree course in naturopathy. Sadly, the taxpayer-funded Australian Broadcasting Corporation, the ABC, has the dubious distinction of winning the bent spoon the most amount of times, with 3 awards under its belt, including one for the pseudoscientific show Psychic Investigators, another for their programme Second Opinion, which was nothing more than an uncritical presentation of many forms of quackery, and a third for their New Inventors programme, which broadcasted the blatant pseudoscience of the anti-bio water conditioning system. That's over $1 billion of your hard-earned taxpayer dollars at work there, Australia. Be proud, money obviously well spent. And surprise, surprise, the ABC has 2 nominations for this year's award, as does the special broadcasting service SBS, which is also partly taxpayer funded. Other nominees include Melbourne University, Good Price Pharmacy, the University of Newcastle, the University of Technology Sydney, Peter the Rainmaker, and even Prime Minister Scott Morrison. Tim Mendham from Australian Skeptic says Aldi were added to the 2019 nominations list for selling ear candles, a product with no known medical benefits and known to be potentially dangerous.
Yes, Aldi does join an illustrious fraternity of people who are very worthy of Ben Spoon. The Ben Spoon.
Hello to the University of Wollongong.
Hello to the University of Wollongong. Hello to the ABC. Hello to a whole range of people. The Ben Spoon, of course, goes to the perpetrator of the most preposterous piece of pseudoscience of the paranormal, which is terrible for microphones. And every year we go through a whole lot of nominations for some person or group that has done some particularly sort of outrageous or pseudoscientific endeavour. And
all right, so what are ear candles?
Ear candles are objects that at some stage were being sold in Australian chemists, actually, which is very depressing. They are little packets, look like candles. You basically stick them in your ear and you light one end, and that's supposed to draw wax out of your ear.
Oh, it
and anything
draws the
else
wax
that's
out
nasty
from
in your
the
ear.
ear. Oh, right, okay.
Yeah, the trouble is when they
What's it do to
initially
your
came
hair?
to the market, well, yeah, well, or wax would drip down the ear candle into your ear, and then they started putting on this little sort of sleeve around it, which is supposed to stop wax flowing. But I've seen people, and I've put people to challenge this who were big proponents of ear candles, and I said, okay, show me how it works, and they showed me how it works, and they sort of open it up, and all inside is this sort of goopy wax, typical stuff you get out of your ear, looks like. And then I said, okay, burn it again, but don't put it in your ear, just let it burn. And they burn it, and then it opens up, and there's exactly the same amount of wax. So basically, the wax you're getting out of an ear candle burning is not from your ear, it's from the candle itself. But the trouble is they're dangerous as well. So they don't work, they're stupid, and they're dangerous. So
how does it pass consumer protection laws, Bob?
I don't know. I really don't know. I think basically it's just a thing that comes and goes.
It's there 1 minute, gone the next, and it's all over before Consumer Affairs can actually do anything about it.
Pretty much so. Yeah, it's the sort of thing that you see, if you see it in Aldi, it's gone again the next week, and you go, oh, I should have bought that at the time. Not the e-candles, but something else perhaps. So yeah, it's the sort of thing that disappears. But they were prevalent in chemists a number of years ago. 10 years ago, we had a big campaign to sort of name and shame chemists for actually selling this stuff, and it gave it an imprimatur. That was sort of that, this must be true if it was being sold in chemists. I don't know if it has the same thing being sold in Aldi's, but of course it's shonky stuff, and unfortunately at the moment it's sort of sitting there in our nomination bin for Ben Spoons, along with SBS, along with the University of Melbourne, along with University.
Do?
SBS's program on, what was it called, Medicine or Myth, had a panel headed by Charlie Teo, who's a neurosurgeon who's also had a bit of a run-in with the skeptics from time to time, and people come and put forward these alternative cures. Some of them are just out and out totally wacky, and others sort of, this panel decides, oh yeah, that's interesting, and maybe we should investigate further. The trouble is the panel is so nice, there is no critical thinking involved in what they're doing at all, or doesn't seem to be, and really sort of anything is valid, but some are more valid than others, apparently, even though the vast majority of this stuff, even the totality, is really without any sort of real medical foundation at all. And it's things referred to as psychological acupuncture, things that are sort of going
but
through...
But the real acupuncture doesn't work. Why would the psychological version work?
I know. All sorts of different things that are thought field therapies that are being put forward. The trouble is this is sort of, even sort of having these things on TV gives them credence. University of Newcastle is having a professor who's promoting all sorts of complementary therapies, Reiki, meditation, guided imagery, all sorts of different things that are iridology, naturopathy, reflexology, under a university course in complementary therapies in healthcare.
And your taxes are helping to pay for that. Aren't you proud?
I know. ABC appears again for a program on landline.
Now, I've got to make a disclaimer here. I have worked with people who work on landline. I, of course, have worked at the ABC for most of my journalistic and broadcasting career. Go, Sycamore. What's the story?
The ABC, occasionally they trip over themselves, and Landline had a program about biodynamic farming.
Biodynamic farming, what's that about?
Biodynamic farming is basically has a whole range of things. It's sort of growing crops and things by the phases of the moon, using things like cow manure shoved inside cow horns and buried to produce a special brew that can use on farming. A lot of people use, or some, not a lot. Occasional people use it in the wine industry, and they actually sell it on the basis of its biodynamic background. There's nothing to show, apart from anecdotal evidence, that biodynamics works at all, actually. But you'll find it in sort of organic greengrocers and some...
I've got to admit, there is a bit of a joke outside the ABC that people who work in the ABC are really part of a sheltered workshop.
That's cruel. But the winner of the Benspawn will be announced at our annual convention.
That's in Melbourne this year.
Melbourne this year, that's right, on the first weekend in December. And so we have a gala dinner, and we announce the winners there, the Ben Spoon, plus our more positive awards, which are supporting people doing good work.
And I guess you guys must therefore keep a close eye out on the Shonkies, the awards brought out by Choice Magazine, the Consumer Affairs magazine.
Yeah, it's always interesting. I was at the announcement just the other day, actually. This particular year, they didn't have anything particularly sceptical or of interest to the skeptics. There was very much more sort of large. A lot of them were sort of financial services industry awards. But often in years past, they've had awards for things which have been totally pseudoscience, and that's very much up the skeptical alley. So, we keep close contact with Choice because in many cases we work together on various projects and things.
That's Tim Mendham from Australian Skeptics. And you really should check out all the Bent Spoon Award past winners, as well as the 2019 nominee details at the Australian Skeptics website. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audioboom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.